All right, this is day 2 of Trig Identities. Hopefully you have your formula card and we're ready to go. Okay, first of all, I just want to give you some problem-solving tips as you work identities. Write these down and refer to them if you get stuck. Okay, number 1, work with one side of the equation at a time. Usually it's the left side. Start with the more complex side. So start with the left and keep the right the same and carry it down. Number 2, look for factoring, adding fractions, substitutions, or other tricks to simplify your equation. 3, always use sines and cosines. This is your go-to thing. Replace with sines and cosines if you can. And number 4 is just to try something. Don't do nothing. There's something here you can do, or it wouldn't be an identity. Okay? So let's try some of these. All right. Now, cosecant squared x minus 1 over cosine x equals cotangent equals cosecant. So this is the side right here we're going to leave, right here alone. All right? On the left, we're going to look for replacements. So cosine we like. Everything sines and cosines is good to go. But cosecant, you need to look on your formula card, and you should notice an identity that says cosecant x minus 1 equals the cotangent squared of x. Now, you're saying, well, that's not really sines and cosines, but it can help us. So that's the direction you want to go, because this is simpler than this. So I'm going to replace it with cotangent squared of x and leave the bottom as cosine x. Okay? Now, how do you break this up? Well, split this guy up. What you really have is cotangent of x times cotangent of x. Remember, all these are 1 because they're in numerators, times 1 over the cosine. Right? Now, cotangent, you also have this on your chart. Cotangent of x, or theta, is cosine of x over sine of x, right? So now I can replace one cotangent with this guy. So I'm going to leave one cotangent alone, because if you look on the right, you still need one. So I'm going to take the second one and replace it with cosine x over the sine x times 1 over the cosine x. All right, now let's see what we can do to simplify. Notice this. Notice that these two cancel out. And if I multiply the parts that are left together, I have 1 over sine x, right? If you look on your card, what is 1 over sine x? So 1 over sine x is cosecant x, all right? So cotangent x times cosecant x. And that is what I wanted. Really, you should write this each step of the way, right? The right side of the equation along your way. I have a bad habit there. Because it keeps fresh in your mind what it is you're going for. All right? So this would be your final step, showing you have proved that the left is equal to the right. Let's try this one. Okay, you've got parentheses and you've got binomials multiplied together. So what you're going to basically do is FOIL, guys. Just FOIL or box it, however you want to do it. First terms, I get 1 times 1 is 1. Outer, minus sine of beta. Inner, plus sine of beta. Last, I get negative sine squared of beta equals cosine squared of beta. Okay? Now, look, it's a difference of squares, isn't it? So these two cancel out, and what do I have left? 1 minus the sine squared of beta equals the cosine squared of beta. That is one of your identities indeed. So you can replace 1 minus cosine squared of beta with cosine squared of beta. Sorry. 1 minus sine squared of beta, replace it with cosine squared beta. All right. That was a simple one. Even though it looks complex, it really wasn't. It really went rather quickly. Let's try another one. Look at this. This binomial is being squared. So first thing I'm going to do is multiply this baby out. Tangent of x times or plus 1. Tangent of x plus 1. Okay, first thing I do is like multiply it out because it's squared, right? So I want tangent of x plus 1 times the tangent of x plus 1. Okay, secant squared x plus 2 tangent x. All right, multiply it out. First terms, tangent squared x. Outer terms, just one tangent, plus inner terms, another tangent. Last terms, 1 times 1 is 1. Combine like terms, I get tangent squared plus 2 tangent of x. Okay, notice the difference there. These two are multiplied, these two are added, plus 1. Okay, it's still equal to secant squared of x plus 2 tangent of x. We're beginning to see parts show up. Look, there's our 2 tangent x, right? Now, if I rearrange this, I can do it because it's just addition. If I put tangent squared of x, sorry, I should have my x there, plus 1 together, plus 2 tangent of x, I have not changed the equation. I've just rearranged here on the left. Now, the reason I would do that is because if you look on your card, you will see tangent squared x plus 1, you can replace with something, okay? And what are we looking for to replace on the right? Well, we're looking to see if it can be replaced with secant squared. And you should find that identity, yes indeed. Secant squared of x is tangent squared of x plus 1. That is right off your card. So I can replace it, plus 2 tangent x equals the secant squared of x plus 2 tangent x. Okay, so even though it looks a little more complex, it was not so bad. All right, the way to get good at these is to keep cranking at them and get familiar with these identities. Last one. All right, cosine squared of x minus sine squared of x equals 1 minus 2 sine squared of x. So notice we have cosines and sines on the left and we only have sines over here. So that's one clue of the puzzle, is you want to get rid of the cosine somehow. So the first thing I would do is look at my identities chart and see what can I replace cosine squared with. Well, if you look on your chart, there is an identity that says 1 minus sine squared of x. So I'm going to replace this guy with just that. 1 minus the sine squared of x, that's the cosine, right? Minus the sine squared of x equals 1 minus 2 sine squared of x. All right, so I can really just drop my parentheses. I did that just so you could see I was replacing cosine with that alone. Minus sine squared of x minus sine squared. Okay, this is like -1 and -1. If you put them together, you get -2 sine squared of x. Don't forget that 1 hanging out. And look, that is equal to the right side of your equation. And we're done. Okay, not so bad. All right, be ready in class and we'll do some more of these.